Great. Actually, let's turn you a little bit that way so the door doesn't show up. Oh, that's going to be nice. That's going to be nice. And I will turn this down. Hello.
Hi.
We are at the American Geophysical Union annual fall meeting in Washington, D.C. How many AGUs have you been to?
This is my third one.
This is my second. I love it. It's a great place for me to connect with scientists from the University of Alaska Fairbanks that I don't usually get to see because we're all busy doing our same things. It brings everybody together. And the collaboration of AGU is something that's so important for science, is what I've heard.
Yeah, for sure. I really enjoy getting to connect with people I know and people that I get to meet and then form new relationships with.
You're doing a poster session presentation, about 300 yards. That way the poster hall is huge behind you. And it was someone from the UK, is that right? Mm-hmm. Or where did you just met a new scientist?
Yeah, I did just meet a new person.
And
yeah,
it could be a new collaborator.
What posters are for.
Yeah. You network, plus you can recruit for your department.
Yes.
Where do you work on campus?
I am in the chemistry department, so I'm part of our environmental chemistry program. And so we're up on the hill in the Reichardt building.
The environmental chemistry, that sounds very important. I live in the environment.
Everyone does, yes.
But you are presenting about, as the permafrost is thawing, which we've heard so much about, and we're going to hear a lot more about over the next years, as it really starts to really thaw. It releases stuff that's in there that's never been released before.
Potentially,
and it might get into water that it's never been in before.
Potentially, yeah. So a lot of permafrost, especially near the Fairbanks area, has high carbon content. And so that carbon can potentially be then processed by different microbes as it moves its way from the soils into different aquatic systems. And so part of what I look at is trying to understand where that organic carbon group is and how that functional group distribution is changing. So what part of the carbon pool moves when permafrost thaws, and how that then might be impacted into different surface waters.
Is carbon poisonous in itself?
No, not at all. It's it's a natural part of the food chain. So microbes need to be able to. Some are able to eat it as a source, or eat is the wrong word, but process that material as a source.
Eating works.
And, I'm not a biologist by training, so my vocabulary with microbes is a little rudimentary, and so
something happens in there.
Right. So what I'm interested in doing is really characterizing what that organic carbon pool is made of. What are the specific molecules and types of functional groups in that carbon that might dictate its reactivity or its susceptibility to processing by microbes?
Because that's a big part of chemistry. It's not just one thing. It's like when they mix,
right,
that's when the danger
There's
happens.
There's a lot of different types of molecules. It's a heterogeneous mixture, right? So we use a lot of high-level techniques. Specifically, we use things like nuclear magnetic resonance to understand organic functional groups. We use spectroscopy like UV vis and fluorescence to look at what can react with light. And we also use instrumentation to analyze inorganics like metals. So we use ICPMS at our Advanced Instrumentation Lab, which is also part of CNSM, to be able to kind of get a holistic picture of how that entire system is working.
Let's take a little sidetrack to the Advanced Instrumentation Lab. Do you get to work in there and use some of that equipment?
I do, and my students do, which is fantastic.
We'll talk about that in a second, but there is such amazing technology. They're just getting new equipment all the time to do more and more detailed analysis of samples up there. What's up in the Advanced Instrumentation
So
Lab?
our two flagship instruments are we have a state-of-the-art electron microprobe, which allows you to look at solid materials with very fine spatial resolution and characterize their composition. And then the other flagship instrument, the one that I use most frequently, is the ICPMS, which stands for Inductively Coupled Plasma Mass Spectrometer. And that allows you to get trace level metal concentrations in different types of solutions. And so it's really popular. It's used by a lot of different groups on campus and for a lot of really important different types of research, not just looking at permafrost, but many different types of varied fields.
Did it start out where you could use it whenever you wanted, and now you've got to schedule some time in the tightening constraint of using it?
No, it's always been pretty popular since I've been here, but I'm still new. I'm in my 5th year, so I still qualify myself as new.
One of the things I heard you talking about the poster, and you just mentioned it too, was the passion you have for working with students and encouraging student research and getting undergrads and graduate students to do their thing for real.
Yeah.
Why is that so important for you?
For me, it's really important to be a part of that process of helping see students develop and become independent scientists. So my group currently has 4 graduate students and 4 undergraduate students in it. I have a couple new undergraduate students starting in the spring, and I really just like to get people involved in getting their hands dirty a bit with real research, and I find that that helps build scientific identity, gives people really translatable skills that then can help them move on to whatever their next steps are, and that interaction is just so rewarding and positive, and it's been such an awesome experience.
And you get the joy of like, oh my God, they made a finding.
Yeah.
They published a paper. To help out a little bit with that, it's that inter-lab collaboration that must feel great.
Right, yeah, no, it's really an exciting piece of what I do.
For people in Fairbanks, and the thing that you mentioned before was you're part of a larger puzzle that's being put together to analyze how Fairbanks is changing as the Arctic thaws. What part of the puzzle is yours?
So mine is really looking at aquatic chemistry. So the project that I presented here at AGU is a collaboration with some faculty in engineering and also in biology. So we're a large collaborative group. And my piece is really looking at that chemical composition, and so what these different molecules are made of and how they change over these different gradients of change.
So if you're going somewhere to dig something up, you want to know what water is going to come out from there. Or if you're going to plant a garden, you want to know what water is going to be feeding those plants.
Potentially, and that's coupled with knowing where that water moves, how that water moves, knowing where permafrost is, right? And so there's a lot of different pieces that come together to really understand a system as a whole.
Is there new water in Fairbanks? Fresh water, not fresh water, but water that's never been seen before? Water sources?
That I don't know. That'd be a great question for our hydrology collaborators.
That's great, and that's also one of the important things of science is like, I don't know, ask this person, because I've got my own research to worry about. Thank you so much for taking a few minutes. I like to shake hands across the camera.
Sure.
I know your poster is very, 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 very popular, so thanks for taking a couple minutes to talk with us on YouTube is where we were this time around, and I'll share the link later.
All right.
Thanks.
Anytime.